I'm going to talk through question 8 and 9 from the AQA chapter test number 7. So question 8 is this. If you haven't got it written down, I would pause the video and write it down. So a particle moves in a straight line such that its displacement s is given by this, okay, where t is the time taken. So you've got s equals 12 plus 4t cubed, take away 3t squared. And you've been asked to write down a formula for the velocity, but we've been given the displacement. Okay, so we should know from before. So we've been given displacement, we've got that, but we want to find velocity. So to get from displacement to velocity, I need to differentiate. Okay, so for A, I need to differentiate. So to find V, okay, we've got to differentiate S. So we've got ds with respect to t, differential. So when you differentiate 12, you get nothing. When you differentiate 4t cubed, we get 12t squared. When we differentiate negative 3t squared, we get negative 6t. Okay, that's it. We've been asked for the velocity and we've given the velocity. Next is write a formula for the acceleration. So again, we can see from here, we've now got velocity. We've now been given velocity and we want to find acceleration. So to get down here, we need to differentiate again. Okay, so that was A. So for B, we need to differentiate again. So acceleration is equal to the differential of V with respect to time. When you differentiate this, we get 24t. When we differentiate this, take away 6. And that is our formula for the acceleration, which we've been asked for. And then it said work out the times, so that's A, I, work out the times when the particle is at rest. When the particle is at rest, its velocity is going to be 0. Okay, its displacement is not going to be 0 because, as we know, displacement can be positive or negative. It doesn't have to be 0. Okay, whereas velocity will be 0. It'll be travelling at a speed of 0 because it won't be moving. So we want to use our velocity, which we found in the first part, and we know that we want velocity to equal 0. Okay, that's an important step, just showing that you know that the velocity does need to equal 0. So then we can solve this, we can factorise, we can take out 6t, so 2t take away 1. Okay, so either 6t equals 0, and therefore t equals 0, or 2t take away 1 equals 0, and that means that t will equal 0.5. Okay, and that's it. The question didn't say whether times in seconds, but we assume because our displacement has been given, so I'm just going to put seconds, but we're going to move on to question 9. So if you haven't got this written down, I would recommend you write it down. It's really important. Maybe put it on a revision card or something like that. Okay, the next question is this one. Okay, so I recommend, if you haven't got this one written down, that you pause the video and make a note of the question. So it says, what is the initial velocity of the bullet? So we want to, working out A, we want to find the initial velocity. Well, velocity has been given to us. We know that velocity is equal to 343 take away t cubed. If it's the initial velocity, then t is going to equal 0 because that's when it starts. So we know that t is equal to 0. Well, 0 cubed is 0. So we know that our velocity initially is 343. And it gives us our units in the question, meters per second. Okay, The next one, B, it says how much time passes before the bullet comes to rest. So we want to make our velocity equal 0 because at rest the speed is 0. So we've got V equals 343 take away t cubed. We want to make that equal to 0. Okay, we're going to then solve. And the cube root of 243 is about 7 seconds. Okay, and then C says how far does the bullet travel in this time? So how far does it travel kind of symbolises that we need to find our displacement, our S. Okay, so going back to this, we now have our velocity, but we want to find how far, so we want the displacement. So we've got the velocity and we want the displacement, so we want to get up to displacement, which means we're going to have to integrate this time. Okay, so we've got V equals 343 take away t cubed. We want to integrate, so when we get S, it's the integral of this. Okay, so you can always put S is equal to 343 take away t cubed dt because it's respect to t. So when you integrate this, we get 343t take away t to the power of 4 over 4. Okay, and then it says how far does the bullet travel in this time? So you're using your answer from B and you're going to substitute it in, okay, to kind of help you, but I've forgotten my constant of acceleration. So I can find my constant because I know that when t equals 0, I know that its displacement is equal to 0 because it starts from the gun, the bullet starts in the gun, so the displacement will be 0, and therefore if I was to substitute that in, I would get that c is equal to 0. So I don't really need my plus c, well the plus c is 0. So I've got S is equal to 343t take away t to the power of 4 over 4. But I want to sub in t is equal to 7 from B. So t is equal to 7 seconds. So therefore I know that S is equal to 343 times 7 take away 7 to the power of 4 over 4, which is equal to 1,800 meters. That's to 3 significant figures. Okay, so kind of need to use this to help us each time. I would put this on a revision card, write it down, make sure you're happy with it. It helps us every time we're kind of asked to use calculus when we're working with kinematics. This is what we need to be focused on.